I look around, I only see two people who don't have their periodic table out, and I shake my head in dismay. I have mine here. Yeah, it's only been 3 weeks that we've been poring over this document. Getting used to it? Sure. Again, let me make sure you understand. Someone asked me the other day, are we allowed to bring this to the test? I'm going to say, you have to bring this to the test, because I don't think, there may be people that have actually memorized the entire periodic table. I've never bothered. You not only can bring this to your test, you really, 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 really almost have to. Next unit, we'll be talking about the back page. You may have looked at the back page and wondered, what's that stuff? What are polyatomic ions? I kind of know what the word ions means. It means it has a charge. What's that polyatomic? I don't know. Anyways, front page. So there's going to be a version of this on your test as well. Mg, that is that magnesium or manganese? I always get those two mixed up. I have to be careful. It's magnesium? Magnesium. I didn't leave much room to write, but there you go. I found it. Atomic number 12. 12 protons. Oh, 12 electrons. Neutrons, I have to do some math. The atomic mass is 24.3. Round off 24. By the way, I didn't have a column here for atomic mass. I could certainly add that if I wanted to. 12 neutrons as well, yes? Yep. How many valence electrons? There are many shortcuts, but when in doubt, count. 1, 2, 2. I am not going to give you ones way down here that are all freaky and weird on your test. How many electron shells? There are many shortcuts, but when in doubt, count this way. 1, 2. What's the period? Second period. What's the family? Family 2. Atomic number 15. I don't know that one. Phosphorus. Am I wrong? Period 3. I'm sorry. Period 3 and 3 electron shells. I was looking through and counting wrong. Here I said to count. Okay? Sorry about that. That's my fault. Thank you, Candy, for you for finding a mistake. So, anytime I make a mistake, catch me in it. I never make mistakes. See? That one doesn't count. Atomic number 15. Phosphorus, you said? So that's P, and that's phosphorus. One of phosphorus's unique properties is in air, it will burst into flame. We have found, sadly, nasty ways to make use of that. It's illegal, but in wars, phosphorus has been laced into bullets so that when the bullet enters you, no problem. But when the surgeons are operating on you and expose the wound to air, it bursts into flame. So the workaround is surgeons will actually operate underwater. So they'll submerge the limb or whatever is in the, not the surgeon themselves, they submerge the patient in water so their head is above the water still, and they'll have to operate underwater. But it's just, it'd be nicer if we... Now, by the way, there are also really cool uses for the fact that phosphorus will glow or fluoresce or burn in air. So there are good uses as well, but that's a creepy one. Number of protons, 15. Number of electrons, 15. Number of neutrons, I got to do some math. 31, take away 15. 16 neutrons, is that right? Yep. Now, I'm going to count without holding this facing you, because I couldn't do that. I have to have it facing me. Number of electron shells, 3. Yes? Number of valence electrons, 1, 2, 3, 4, 5. Period 3, and family number 15. What's right above phosphorus? Nitrogen and phosphorus will combine chemically in similar ways. That's why they're in the same family. As will arsenic, as will antimony, as will bismuth. Argon. What happens to students on Friday after school? They are... Okay, AR. Atomic number 18. 18 protons, 18 electrons, because it's not an ion. Number of neutrons, 39.9, so 40, take away 18, is 22? Number of valence electrons, it has a full shell, 8. Number of electron shells, 1, 2, 3. Period 3, family 18. What's the fancy schmancy name for family 18? It's on your periodic table. Okay, noble gases. I'll feel free to say that and expect that you know that it's on your periodic table and you can figure out what we're talking about. They used to be called the inert gases, but now we know that a couple of them will react, so noble gases. Number of protons, 9. That means the atomic number is 9. Atomic number 9, fluorine. Ooh, capital F. Fluorine. Number of electrons when it's neutral, 9. How many neutrons? 10? Number of valence electrons, 7, which is why it's so reactive. It just needs one extra electron to have a full shell, so it will grab that any way that it can. Number of electron shells, 2. Period number 2, family number 17. We call those the halogens. Number of electrons, 16. That means we have 16 protons. That means we have an atomic number of 16. Symbol sulfur. S and sulfur. In North America, we spell sulfur with an F. Sometimes you'll see handouts, if I've lifted them from Britain, that they spell sulfur with a PH. It's going to happen sometimes. Number of neutrons, 32.1, take away 16, also 16. You're noticing sometimes the neutrons match the protons. Do they always match the protons? No. And the further down you go, it won't happen. So if you go into the 80s or 90s and do the math, you'll notice you always have way more neutrons than protons. By the way, that's one of the things that makes those nuclei unstable. That's one of the things that allows us to split those nuclei. That was the atom bomb. Little hashtag nerd trivia for you there. Valence what was I looking at here? Sulfur, valence electrons, 1, 2, 3, 4, 5, 6. Number of electron shells, 3. Period number 3. Am I right? Am I counting wrong? 1, 2. Now you got me scared that I can't count. And it's in the family 16. "53 protons, atomic number 53. I got to go hunting for that. Oh, there we are, iodine. Also pronounced iodine in Britain. You'll hear both. Fluorine in Britain, fluorine. Fluorine. I think we say fluorine in Canada too. But we don't, for some reason, say iodine. We say iodine. I don't know why. Number of neutrons. Oh, I'm going to have to do some math here. 126.9, 127, take away 53, 170, 74, is that right? Yeah. And I've said you can bring a calculator. You can't use your phone as a calculator. You can bring your calculator to the test if you want to. Number of electrons, 53. Number of valence electrons. And this is where, when it's this far down and we have weird stuff happening in the outer shells, the answer is not 17. Number of electron shells, 1, 2, 3, 4, 5. Period number 5, family 17. An element has 80 protons and 120 neutrons. What will its atomic mass be? Somebody, yeah, am I wrong?
No.
Oh.
I thought you asked.
Oh, okay. You like the answer?
Yeah.
What would the atomic mass here be?
200 or 226.
No. 80, 120, 200. Now, if you look that atom up, element number 80, it's mercury. Its average mass is 200.6. This one here has lost a neutron. It's radioactive, some types. So, by the way, the fancy word when neutrons change. You've heard the word before, but now you know what it means. Isotopes. Isotopes are the same elements with different number of neutrons. So you'll hear us talk about carbon-14 versus carbon-16 versus carbon-15. Those are all isotopes of carbon. You'll do that in Science 10. Now, if you said 200.6, I'm not going to take a mark off this time, but for what it's worth, if you're asked to figure out the mass, it's add up the protons, add up the neutrons. That's the mass of that specific, unique isotope. Is that your question?
No.
Yeah, question.
But like, for, like you said, like there's different isotopes
Yep.
of carbon
Yep.
stuff. Well, what does the number after mean?
The mass of that particular isotope. What's carbon's average mass? Carbon's average 12. Okay. Carbon-14 is radioactive. It has 2 extra neutrons. It has a mass of 14. That's how I know it has 2 extra neutrons, because normally the mass is 12, and it can't gain protons. If it gains protons, that's a different element. Okay. Carbon-14 is the one we use in carbon dating. That radioactive decays at such a rate that when we look at fossilized or old living things, we can calculate how much carbon-14 is left in it and figure out when it must have first been formed. All of you right now, since you were all born after the first atomic bombs were launched, there is more radioactive material in the atmosphere since 1945 than before 1945. So if we actually took a specimen from you and we compared it, if any of you have great-grandparents, people that were born before 1945, they would have a different level of radioactivity than you do. Different, and it's not carbon in that case, it's... starts out as uranium and it decays into something and it decays. I used to know what element it was, but I can't remember. It's a very, very minor, small trace amount, but it's very noticeable. If we were looking at other planets, for example, we would easily be able to tell whether they had discovered atomic energy or not. It stands out pretty quickly. Oh, there's some radioactive stuff that normally isn't here. What element is this a model of? 20 protons. It's got to be calcium. You could write the word calcium, but I tend to agree. What element is this a model of? Now, this is a 3-dimensional model, and I'm really not sure. There might be some protons tucked behind there that I can't see. I'm going to assume this is an atom because they did not put the square brackets and the ion charge, and that's why we do that, so you can make that. So I can also count the electrons. 6 electrons, I'll assume 6 protons. Carbon? Oh, what ion is this? Did they tell me the number of protons? So what element is it? Because that's what determines everything. It's lithium. What if they had colored that in? Could I still figure it out? How?
You could count the number of electrons and ion charge.
How do I know it's not helium? Oh, okay. Because if I count the number of electrons, it still might be helium, which has 2. But the ion charge. So that would be a tougher one. I might do one like that. I don't know. What ion is this? Oxygen? Now, all of you that wrote O, you're going to do something a little weird that I'm going to explain in the next unit. Put a 2 because it's actually O2. Oxygen is so reactive that if there's nothing with it for it to react with, it will react with itself and it will combine with itself. You will never find a single solitary oxygen atom floating by itself. Instead, you'll have found that it's bonded with another oxygen atom. That's why if you actually see tanks, they're not even called oxygen tanks, they're always called O2 tanks. We just do it habitually. There are some atoms that are like that. Hydrogen is like that. Fluorine is like that. You'll learn that. So you don't find a hydrogen atom by itself. If there's nothing else for it to react with, it's going to react with itself and form H2. It's going to share electrons to get that full outer shell. Draw a calcium atom and a calcium ion. This one I was a little bit mean because I think you have to add an extra little shell. Yeah. Although, wait a minute, did I give you calcium on the previous page? See how nice I was? Maybe you spot that? So calcium, 20p plus, 20 neutrons. That doesn't look good. 20p plus, 20 neutrons, and I usually tend to... Now, if you don't put the element name there, you can still figure it out from the number of protons. This is an atom, So I'm going to have 2 in the first shell. 1, 2, 3, 4, pair, 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 pair in the second shell. 1, 2, 3, 4, pair, 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 pair in the third shell. And then how many do I have in the fourth shell? Okay, I guess I'm going to have to freehand. This is going to be ugly, but that's okay. Yes, the tongue helps. 1, oh, that's, screen moved on me. 1, 2, it wouldn't pair yet. It only pairs once half the shell is full, then they pair, 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 pair. Why is that? That's a quantum physics thing. I can't give you a better explanation than that, except to say, because it does. Because of a 2-page long equation, if you really want the honest truth. If you hear them talking about quantum computing and qubits and electron spin, it's that stuff. Again, let me be clear. Electrons don't exist in nice little circular patterns as dots, but this is a good model. Ion. Still Ca. Still 20p plus, 20n0. Still 2 in the first shell. Still 1, 2, 3, 4. Pair, 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 pair. And 1, 2, 3, 4. Pair, 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 pair.
That's it. 'Cause you have an ion.
It's not it.
You get back for
You need the bracket.
Yes.
And the 2 plus.
By the way, that last step, kids, because they're so proud, they've got the electrons right. They're so proud. They often forget to, no, but I've seen it before. The kids forget this one because they're so proud they got the hard part, and then they forget the whole 2 plus. Okay? And if you're writing a calcium ion but not drawing the diagram, easy way to do it is Ca2 plus, and I'll know what you're talking about. Okay? Is that all right? So that's for you to hang on to study from. If you didn't finish it, you can try it yourself. I will post an answer key online. What are we working on today? A couple of things. First of all, last day I gave you this thing. I have 3 answer keys you can work on. I'm going to be throwing a whole bunch of work at you today, but Monday is going to be just a work period, no new lesson. Okay? So let me tell you what you're going to be getting today. First of all, you're getting a quiz.